All right, so I'm gonna go over 1.5 first quickly. Okay. So pretty much I'm gonna run down on 1.5. So this section is talking about uh homogeneous and non-homogeneous system. So linear system, sorry, this is solution set of a linear system. So here's the definitions. All right. A linear system is called homogeneous. Okay, a linear system homogeneous. Okay, so what that means? It means that if the system can be written as AX, let me say AX in the bar. I told you what that means. A bar, upper bar means that this is a column vector, and then zero vector right here. Okay, so here's here's a note. The first one, AX equals B, I mean, the homogeneous always has trivial solution, which means that zero vector is a solution, always. Okay, so this one always has the trivial solution. Let's say it's trivial. Trivial solution is nothing but zero vector. Zero vector. Okay. The second one, a non-trivial solution. So a non-trivial, let's say non-trivial solution is a solution. The x is not equal to zero vector. Okay. Then now third one. Okay. Since the homogeneous system has, I mean, always has a trivial solution, right? So the system, homogeneous system is always consistent because it has at least the one solution, zero vector, right? So a homogeneous system is always consistent. Okay. Next one, uh, last one is a homogeneous system. Oh, okay. So homogeneous system has a non-trivial solution. Okay, solution, which means that if and only if and only if means that necessary and sufficient condition is in symbol mathematically it is. Okay, this means if and only if. Okay. Think about this. Homogeneous system has a non-trivial solution means that the system in a view of matrix equation, this the system, okay, is inconsistent. I mean, at least the one, sorry, not inconsistent. The system has at least the one free variable. Okay, that's actually theorem 2 in page 24 in textbook. Okay, so think about this. Why anyone can tell that the reason why the system has at least one free variables? Anyone? Because think about this. Let's say A is like this: A11, A12, okay, through the A1n, the A21 through the AM1, A22, the AMN. Okay, this is A. And the X is X1 and X2 through the M, right? Okay. And then right hand side is zero vector, 0, 0, 0 through the 0, right? Okay. So size of matrix A is M by N, M by N, and then the x, or this is the n by 1. It should be n, right? Sorry. N by 1. This is 0 vector, which is the n by 1. Okay, like this. Okay, so now if this one in matrix, I mean, every single column is a pivot column, which means that when you row reduce the matrix A, then I told you, assuming that the matrix A, every single column is a pivot column, which means that every single column has pivot. Then when you reduce the row reduce matrix A to get echelon form, then we get something, non-zero entry in right here. First pivot position. Positions, here's the position like this, and then here is 0, and this is non-zero, something like this. Okay, right? And then using the backward substitution, 3D. I mean, think about this. This is what? Let's say this is from the system of equations, and then we want to solve the system of equations. So we reduce the matrix A to echelon form. So, and then assuming that all of the columns are pivot columns, then we're gonna get something like this. This is EF echelon form, okay? Then solving, the system reduced by elementary operations. So something non-zero number times xn equals 0, then xn must be 0. Doing that, it turns out that, the x bar is a 0 vector. So in order to get a non-zero solution vector, one of them, I mean, the last one must be 0. So that xn can be any number, right? 0 times any number is just a 0. It makes sense, right? Or not this one, maybe, yeah, so 0 right here. Okay, it means that, the one of columns, even, this is not 0, but if this is 0, maybe it happened. So it means that at least the one of column must be non-pivot column, which means that the one of column must be a column corresponding to free variable. So it has to have a free variable to get a non-zero solution, non-trivial solution, I mean. That's why the homogeneous system has unique non-trivial solution if and only if the system has at least one free variable. Okay. So, okay. So, okay, so now see example. Yeah, so look at the example 1 and 2 in textbook. Okay, but let me see. This is the problem number 2 in exercise in section 1.5. So it's a 1 and -2 and 1 and -3, 1 and 2 and a 7, -4, 9. And this is the augmented matrix like this. And so we want to see if this system, definitely this system is homogeneous, right? Because look at the, this is augmented matrix. So matrix B is a 0 vector. So augmented matrix, by looking at the augmented matrix, then, it turns out that, oh, this is homogeneous, okay? So now we want to figure out if the system, homogeneous system, has a non-trivial solution. So we do applying the elementary operations. So we row reduce to get EF. So echelon form. So do this, then do 1, 0, 0. Let me, skip, some step applying the elementary operations because this is tedious. So here 0, 0, 0. Okay, so do this, and then 1 and 0 and 0 and -3 and -5 and 0 and a 7 and 10 and 12. Oh, here's 0, 0, 0. Okay, so we got what? As you can see that there are 3 pivot. We got, for each column we got pivot So we got 3 pivot position, right? So all columns are pivot columns. Okay. So that none of them are free variable in x1, x2, x3. So okay, so this system is has only trivial solution, does not have a non-trivial solution. Okay. So if you want to figure out that this homogeneous has trivial or non-trivial, if the system has non-trivial, you gotta do this. Okay, I did this. But there's other way, actually. Um, uh, so what does that mean? So remember the theorem 4 in 1.4? Theorem 4 in section 1.4, section 1.4. Okay. There is the for statement, right? Remember that? For every B, the system has what? The I forgot, but I think you can find out in the textbook, okay? So one of them is related to this one. So if the matrix equation, matrix system satisfy one of them, then means, homogeneous. Homogeneous, the system will have only trivial solution if that system satisfy one of them. Okay, so just please look at the theorem 4 in section 1.4. I'm not going to go back. Okay, so and then we move to next one, parametric vector form. But let me just quickly go over this. Okay. So sometimes we need to express the matrix system having the free variable as a vector form, and they want to figure out how that solution consists of, which means that yeah, I'll show you. Think about this augmented matrix. Okay, 1 and 1 and -3 and 3 and 4, -7, -5, -8 and 9, 0, 0, 0. Okay, so we do reduce echelon form. Then we're gonna get 1, 0, 0, and a 0, 1, 0, and then 4, -3, 0. Oop, this augmented matrix, right? So right here. Okay, so as you can see that, so we got the 0 row, right? And then in the homogeneous system, we got the 0 row in the very bottom, which means that this homogeneous system has one free variable. Okay, and then what's the pivot? Is a pivot right here. Here's a pivot right here. Okay, so okay, free variable. Then let's try to express the solution as the form of vector. Okay, so column vectors. Okay, so here we see that 1 times x1 plus 0 times x2 plus 4 times x3, which means that x1 must be equal 0. So which means that x1 is minus 4x3, right? So we're gonna rewrite back to the system of equations before we get the vector form of the solution. Okay, so 3x3, because one times x2 minus x3 equals 0. So x2 must be 3 times x3, and then x3 is a free variable, can be any number. So let me say just free. So now rewrite this one as a vector form. So x bar, okay, solution vector is x1 and x2 and x3. I did this one before, but I just want to make sure that you are familiar with this. So -4 times x3 and the 3 times x3, and this is x3, which means that we are trying to express the solution vector as some vector form in terms of x3, which is free variable. Okay, so x3 is a free variable, right? So that's why. So here, the entry in a solution vector, I want to rewrite them as in terms of x3, free variable. So now that we can say this is x3, this is factoring out x3 because x3 is a common factor. So we got -4 and 3 and 1. Okay, like this. So this is called the parametric vector form of the solution. Okay. So now next one, more let me give you a more mm, general, complicated one. Okay. So other one, this is kind of example one, and then example two. Okay, example two. Example two. So think about just only one solution, one equation. Two, the plus 15x3 equals 0. 3 equals 0. Okay. Then x1 gonna be just a 2, because the 3 is negative 615, just a multiple of 3. So the divide by 3 means the factoring out 3, okay? So then we're gonna get x1 is 2 times x2, right? And the minus 5 times x3, right? And the x2 is can be any number, let's say 3, and the x3 is 3. So we got two free variable. Then x bar gonna be x1, x2, and x3. This is gonna be 2 times x2, and then here x2, and then 0, now plus minus 5x3, and then 0, and then x3. You can see that, right? We can say this. So this is equal to x2 times 2, 1, 0, and then plus x3, then negative 5, 0, and 1, like this. So this is a parametric vector form or parametric vector equation. Doesn't matter, okay? So anyway, all we can see that x bar is actually what? I mean, the solution set is nothing but what? Because x bar, what? X bar, we can see that x bar is determined by x2 and x3, right? So we collect all of the possible value for x bar determined by x2 and x3. Then this is nothing but what? Span. What? Two vectors. 2, 1, 0, and negative 5, and 0 and 1. Okay. So you can see that right here. In geometry, what? 2, 1, 0 is maybe like this. Let's say this is 2, 1, 0. 2, 1, 0. Just, view this one as a vector, 2, 1, 0 like this, and then maybe, I don't know, maybe this is the negative 5, 0, and 1, right? So the linear combination of the two vectors will generate solution of this equation. That's a geometric interpretation of this one. Okay. So, okay. Next one is the with see, this is also homogeneous, right? So what about non-homogeneous? So non-homogeneous solution is like this. Let me say this is example 3 in page 52. So non-homogeneous system. Give me a second. Let's say we're doing back to, let me say put here homogeneous system. So so far I was just talking about homogeneous parametric vector form of the homogeneous system. Okay, now I'm going to talk about a non-homogeneous system. Okay. So in a non-homogeneous system, the general solution can be written in parametric vector form is like this. X bar is equal to S times P bar plus T times this T. Okay, T times H. This is H bar. So here, S and T are parameters. Okay. So here's the example. So actually, SP is the solution of the solution of the homogeneous system. So actually, non-homogeneous solution of non-homogeneous system is consistent of the solution of homogeneous plus particular solution. That's what I'm going to show you. So A is this is example 3 in page 52 in textbook. So 3 and -3 and 6, now 5, -2 and 1 and -4, 4, 8. Okay, and B is the 7 and -1 and -4. Okay. So we just do augmented matrix, right? Construct the augmented matrix. Okay. Let me skip writing. Okay, this is augmented matrix. Let's say aug matrix. Okay, augmented matrix right there, and then do REF. So we got 1 0 0. This is your job, okay? So 1 0 0 and 0 1 0, and -4/3 and then 0 0. Okay, and then -1 and 2 and 0. So we got this. So which means that we got two pivot columns here, right? So it's 1 in the first column, and then the 1 in the second row in the second column is 1. So first two columns are pivot columns. Okay, and then last row is just all zeros entry right there. So okay, so we got one free variable. So finally, X bar is going to be what? -1, 2, 0, and then plus X3, and then 4/3, and 0 and 1. Okay, I just skipped the several steps, but I'm sure that you can figure that out. Okay, so which means that this is the vector P, okay, and then this is the vector H. Okay, and the S is 1 and the T is T3. Okay, in this case, there's only one free variable because which is X3, right? This is the column corresponding to X1. Second column is the column corresponding to X2. This is column corresponding to X3, and the X3 is a free. The other 1 is what? Basic. Right? So here. But okay. So now what I'm gonna do? What if X3 equals 0? Yeah. So think about this question. What if X bar is P? Question 1. Question 2. What if X bar is H? I'm sure that one of them is a solution of the homogeneous system. Okay, so for this one, okay, so let's figure it out. So here's a 1. If X bar is P, which means that X3 equals 0, right? So we do this, A times P bar. What happened? A times P bar, we're going to get this. 7, -1, and -4. Right? So that one, yeah, that makes sense, right? Think about this. X3 is a free variable. X3 can be any real number. For any real number for X3, we're gonna the X bar must be a solution. So X bar equals P bar, which means that X3 is 0. In that case, even though X3 equals 0, we should get the B when you multiply P bar by A, because P bar is still solution. This is the case that what X3 equals 0 in the solution set. So A P bar must return B. If not, you got something wrong in here. So this is B, right? Where's B? B right here, right? B, right? So here solution X bar right there, which means that what? X bar is in span, right? -1, 2, 0, and 4/3. Oh, no, not this one. Sorry, it's a -1, 2, x3 in a real number such that -1, 2, 0 in a plus x3, this, right? It's not span, but like this. So for any choice of x3, this one should return the solution. So p bar is a one-up solution, which is the case that x is 3 equals 0. So, yeah. So this is b, right? This equals b. So second one, what if x bar is h bar? X bar is h bar. Okay. Even can you get the h bar from the in parametric vector form? No, right? Well, we figure out what we get. So a times h bar, then you're gonna get 0 vector, actually. 0, 0, 0. So we see that then, okay, h bar must be what? Non-trivial solution of the homogeneous system. So we solved this. A times x bar equals b, right? What does solutions look like? This one solution set must be non-trivial solution. What was a p bar plus, let me say just t, and then h bar. So that p means a particular solution, which means the solution to the ax bar equals b bar, and then h bar, this is the non-trivial solution. Solution to a non-trivial solution. Solution to the homogeneous system. Corresponding to ax bar equals b bar. I think not corresponding, associated. I think this is better. This is width, okay? Width. This is width. Width is sometimes we write this one like this. Okay. So yeah, that's it. So the th in a geometry, th must be, let's say this is the th. Oh, no, this particular solution. Give me a second. Give me a second. Let's see. Let's say this is h, and then let's say this is the maybe p. Okay. Then p plus h gonna be what? Parallelogram rule. We're gonna get this, right? Oh, this, right? Okay. But there is a parameter t. So depending on value of t, this will be elongate, I mean stretch or shrink or going backward, right? Let me draw a line like this. There's a line right here. Okay. If 2 times h may be right here. Okay. So then we do apply the parallelogram rule. Let's see. We're gonna get this right here. So connecting all the line dot, then we're gonna get this. So that's the p bar plus t times h in a vector form. This point, that point, depending on the value of t, we're gonna get all the in a point right here. Connecting them, we're gonna get that line, which is a parallel to the 2h. I mean h. Sorry, th. Okay. So the gap is the what? Determined by the vector p, which is a particular column vector p, which is a particular solution. That's a geometric interpretation of the parametric vector equation or vector form of the non-homogeneous system. Okay, that's all about the, not all about that, but this is the theorem 6. Okay, please do read carefully in theorem 6. That's all that is theorem 6. I was talking about the theorem 6. 1.5. Okay. Keep in mind this, theorem 6. Now, okay, so that's the some brief summary of the 1.5.